In this video, I'd like to talk about the math question of the day for February 7th, 2023. And with this problem, we need to perform the indicated operation and identify the degree of the result, namely the degree of the resulting polynomial, since we're taking two quadratic polynomials and we are multiplying. For this type of problem, we need to have an understanding of Algebra 1 and some of Algebra 2, where we start to deal with polynomials and how to carry out their arithmetic. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted this problem, we can start working through it together. And if you have suggestions for future videos, please leave them as a comment down below. Now, we have these two second degree polynomials, since that's the highest power in each of these, and we're multiplying them together. Now, remember, when dealing with polynomials, let's look at a simple example first. Let's say we have, x minus 1 times by x plus 2. We use distribution. This term distributes to both, and this term distributes to both. X times x is x squared. We get plus 2x, and then minus 1x, and minus 1 times positive 2 would be minus 1, and we can of course simplify this to this quadratic expression here. Now if we added in, let's say, a third term, let's say we have x squared plus x plus 1 multiplied by x minus 3, we would follow out a similar procedure, though now we take each of these three terms and distribute them into both of the two terms over here. So this would go in as well. And so when we multiply these together, we will get 6 terms. And notice that pattern. We took a 2-term expression here, multiplied it by a 2-term expression, and notice we got 4 terms back. If we take a 3-term expression and multiply it by a 2-term expression, we will get 6 terms back. And you can count that out. The x squared will multiply into 2, the x will go into 2, and the 1 will go into 2, in total giving you 6 different terms. And the only difference between this one here and this one here is that now we have a 3-term expression multiplied by a 3-term expression. And you might be able to guess that when multiplying these together, we will get a 9-term product. So when multiplying these together, we will use distribution. The x squared will go to all 3 of them. Then the x will go to all 3 of them in the second expression. And lastly, the negative 2 will go to all 3 of them. So let's work through those individually. We have the x squared multiplying to all 3 of them. So x squared times 3x squared, that would be 3x to the 4th. X squared times minus 8 would be minus 8x cubed. X squared times negative 7 would be minus 7x squared. And now we do the x term, this one in blue going to everything. So we get x times 3x squared, that is 3x to the 3rd. Then x times by minus 8x would be minus 8x squared. And then we have x times by negative 7, which would be minus 7x. And we move to our last one, this green distribution, this negative 2 going to all of those. Minus 2 times 3x squared would be minus 6x squared. Then we have minus 2 times minus 8x, that would be plus 16x. And minus 2 times minus 7 would be plus 14. Now you might notice how I stacked these up. Notice that like terms are lined up. Now, you can definitely do this. It helps keep it in order, but this is ultimately just an organizational skill. You don't need to write it like this. So let's simplify our result. Combine like terms. We only have one 4th degree term, so 3x to the 4th. We have 2 cubic terms. We have positive 3 minus 8x cubed, so that would be minus 5x cubed. And then for our quadratic terms, we have 3 of them. Looks like we have minus 7 minus 8, that's negative 15x squared. Minus 6x squared would be minus 21x squared. Now we can combine the linear terms, the x to the 1st power. There are only 2 of these. And 16x minus 7x would be plus 9x. And then there's only one constant term, so we just add that to the end. So this right here should be our final product of those two polynomials. And we can see that the highest power, the degree of this polynomial, is a 4. And you can check that when you did multiply this out, you did in fact get 9 different terms.